Hello, welcome back to OConnor Racing. This is a CR500 crankshaft with the tin cans. What I mean by that, just a sheet metal covering around the crankshaft, kind of like a stuffer. Inside of these, it's hollow. You can't disassemble this in a traditional manner. If you do, you'll ruin the crankshaft. This is from my buddy in Hawaii, actually. So where we would normally put a plate in here and press the crank apart, if you do that, the plate will distort all of these tin cans and the crankshaft junk. I think this crank brand new, a little under $300, and you can still get parts for it, so it's well worth it and a lot cheaper to rebuild it. The way to get this apart, that's the pin, and that's the old connecting rod. And we have a machine. Let me zoom in on this for you. We used to do this with a die grinder and a cutoff wheel, something like this right here. After we shot the first videos on the TRXs, showing the same problem with the tin cans and the CR250s, we actually built a proprietary machine just to do these Hondas. So we have a machine that we set these up in and cut the pin. And I'll clue you in on something else. We cut all of the cranks apart now, everything, no matter what it is. We find that by pressing the crankshafts apart, you can actually distort these webs just a little bit. And we're always trying to improve processes in here and continuous improvement. I come from a big company a couple of years ago, so we're trying to keep the same philosophy in here. We're always trying to find better ways of doing things without sacrificing quality, but trying to speed things up, and that helps to keep your prices down. So that's why we built a machine, and that's why we started cutting all the crankshafts in half, make sure that we're not going to get any distortion of the webs. So if you attempt to try something like this, you can use a die grinder, but cut it in half, no pressing, and I'll show you how we put it together. Again, this is a 1989 CR500. I think they were all the same all the way up till 2001. Here's our connecting rod kit we got from good old LA Sleeve, Pro X stuff. I love Pro X rods. I use these any day of the week in any make, model, whatever. If they got it, I'm using it. Lower bearing, top bearing, rollers, thrust washers, pin, and the connecting rod. First thing I'm going to do is I'm going to press this pin into this half of the crankshaft. Alright, here's what the web looks like with the pin in it. And again, the tin cans, you don't want to press on this part of it. Out here, this is the steel part. This is the tin can. The steel part, we just support it here and drive the pin right in from this direction. And that's totally acceptable. Right, the lower bearing, the cage bearing, some rods you get, these rollers all stay with the bearing. Some rods you get them and you got to assemble it. I found an easy way to do this. Just take some good old-fashioned Vaseline, 1001 uses, and just spread a little bit inside of here. As soon as this engine is started, this stuff is just going to dissolve. And what it's going to do is just going to be a bonding agent so I can put these rollers in. Once you got your cage bearing all set, next step is just throw the thrust washer on. What I like to do, just work that web in, pull the rod up, and drop the other thrust washer on. Now we get to the tricky part. I'll be the first one to tell you that you do not need an alignment jig to do a crankshaft. You can do it with a square and a little bit of practice, lead hammer, and you can line crankshafts up like that. Not this. You have one shot of putting this together, and what you got is what you got. You can't start smacking this around under initial alignment to get it so it's in phase with itself, so that everything is nice and straight from the center line of this to this pin. So you have one shot to do this. This is why people don't want to do these crankshafts. If you send a crankshaft like this, a Honda crankshaft, CR250s, CR500s, the TRXs, you send a crankshaft like this out to any of my competitors and you get it back and you see hammer marks here, or if you see this pushed out this way, I'll tell you what, brother, you sent it to the wrong shop. You made the wrong call. We do these types of crankshafts almost on a daily basis at this point, and I'll show you how we're going to get this together. Perfectly aligned without touching this with a hammer. Alright, boys and girls, here's a money shot. This is how we do it. What we have here is a custom-made jig. We built this right in here. These two plates were married together. All of these holes were bored while these were together. So everything is perfectly concentric, everything's parallel to each other. We bored a center hole, dead center of these axes here. You put your bottom piece in. This is the piece that I pushed the pin into, and this has no choice but to line up perfectly. If you make something like this, it's going to be as good as your machine work. We have different size bushings. We can do any crankshaft in the world with this thing, but it's only going to be as accurate as your machining. If you want something like this, we have sold a couple of these. If you have to ask me how much, you can't afford it. We sold a few of these overseas, and the guys are loving them. But the function of the jig, I mean, it has no choice but to go together perfect. So next thing we do, fire up the 40-ton hydraulic electric press. We built this in here as well, and you just start coming down with it. At this point, I'm going to take it out, and I'm going to do the rest outside of the jig. Well, here's our final test. Got the assembly done, and come over here to our bench centers and roll this crank around. This test will work. It works very well as long as nothing here is bent. We checked this coming in. This crank was actually out quite a bit. It was out 5 on one side, 5 thousandths, 3 on the other. And let me see if I can zoom in on this a little bit. But if you watch those needles, as I rotate this crankshaft, I'm getting 2 10-thousandths of 1 inch, and I'm getting 4 10-thousandths of 1 inch on the other side. That's basically your hair split 20 times. That's how close this thing is. OConnor Racing.com. Thanks for watching. Hope this helps.